I am speaking on behalf of PI Sarah Tuttle, but we've only just proposed to the NASA APRA call, who, like coincidentally, their panel happens to be meeting, I think, this week, for Maratus, which is a far ultraviolet narrowband imager centered on 1350 angstroms. And the idea is to map the circumgalactic medium using a 6U CubeSat, which I'll talk a second about what that actually is. This is a smaller price cap than the Pioneer call that Carlos was just about to tell us about. I think it's somewhere around like 3 million, which turns out to be not a lot of money. But the idea is to target O6 in emission at redshift 0.3, but to also do a very wide field survey. And so, oops. So CubeSats are a class of research. Hold on a second. Let's see. There was a, oh yeah, I don't know. I made this presentation in like 2 minutes, and there's all sorts of animations that I don't fully understand about it. Microsoft. So CubeSats are a class of research spacecraft called nanosatellites, and a U is a unit, 10 centimeter by 10 centimeter by 10 centimeter. So they can be 1U, 2U, 3U. This one that we've proposed is 6U. It weighs less than 3 pounds per unit. And so what you see here is just a little side view of the telescope and imager design. It's a 3D rendering on the right. That shows the baffles, and so the side carries the telescope, the filter system, and the detector, and the second 3U stack carries the spacecraft electronics and the detector electronics, and you can see a little image in space of a 6U CubeSat flying. So the idea is that this will be a 6U CubeSat with a 20 arc-minute field of view, and 5 arcsecond by 5 arcsecond spatial resolution, and the flux sensitivity, and I added a little minus there. It's so funny, all the little typos you notice in your tables of proposals you've submitted. Haha. 10 to the 2 by 10 to the minus 15 erg per centimeters, erg per second per centimeter squared. And that's actually really similar to the sensitivity of the Galax GRISM and optical data study. And so we've got a 100-degree survey planned, at least 100-degree survey planned over a much larger area than this. And we'll also put 4 30 angstrom wide narrowband filters on. The kind of timeline is listed down here. Basically, you can fly these things for maybe a year or so. And since we've just submitted to the most recent APRA call, the idea would be to have this thing ready to be built in September 2025. So, you know, it's a ways out, but we can dream. And so this is just something that Lauren Corley's helped us assemble with 2 different simulations, kind of predicting the O6 that you would detect in emission, and then some cloudy models that I ran. So showing just that O6 is one of the strongest lines emitted by the CGM at almost all densities over a wide temperature range here. And so this limiting surface brightness that we've put in color is an intensity of around 0.1 to 10 photons per centimeter square per second per steradian. And you can see I've drawn this 5 arcsecond by 5 arcsecond pixel size, which is 22.5 by 22.5 kiloparsecs at a redshift of 0.3 on top of each image. And so the idea of Maratus is to do 2 basic things. One is a deep stare survey in fields where we've got absorption line information, high resolution absorption line information of O6 at redshift 0.3 that's already been confirmed by COS, and to look at like a small sample of these galaxies to really drill down and combine kinematics and density constraints, which are really powerful for constraining feedback models. And then the other is this wide field survey which is over, 100 square degrees, and will, do a whole number of different kinds of science, from searching for hydrogen ionizing emission from galaxies, Lyman continuum emission, providing a statistical sample of low redshift AGN measured in narrowband filters, cross correlations with spectroscopic galaxy surveys for studying the redshift of photometric samples. And so, you can do a whole wide range of science with this far UV legacy survey, which we were proposing to put in Stripe 82. And then I'm just showing this nice schematic here, which is overlaid on basically a quarter of the Maratus field. This is a Galax 2-color image. And then it's just showing the kind of science that we want to do. And you can see one of these fields here is actually on one of the fields with 06 at exactly the right redshift, where it could fall into one of our narrowband filters. And so yeah, it's pretty cool, pretty comprehensive project. Again, still in the early stages. We hope it gets approved. And also, I'm really curious to hear what Carlos has to say about Aspera, which actually is approved. So I'll let him take over before I have to run away.
Oh, thanks so much, Jess. I appreciate it. And sorry to the group about that technical difficulty. My computer just spontaneously shut down, but I'm back now. Jess, I actually had a question for you about this.
Yeah.
So this is a narrowband imager, right? So
yes.
So our first iterations of Aspera were also a narrowband imager, and we ran into tons and tons of problems trying to figure out how to filter. So we need very, very narrow filters. So what actual filter width were you able to get?
We were talking about 25-ish angstroms.
Okay.
So, not super narrow, but we have some justification for this. And, we thought a lot about backgrounds and background subtractions, and we thought that it was achievable.
Okay. And I'll follow up. I just worry a lot about Lyman beta, right, which is right next door.
It is right next door. So we found some clean windows, and we can, our targeted fields, we can arrange it so that they're at just the right redshift where we don't get Lyman beta contamination.
Great. No, that's awesome.